Okay, so first of all, thanks for joining with us for this webinar, and we are glad to share with you for the information regarding to AMR and what Aeon has done in AMR development cycle, and also what AMR could help for warehouse manufacturing use cases. Yeah. So first, I would like to cut in from market perspective to give you a background of how ANR market will be in the future. So ANR market size stood at 1.67 billion US dollars in 2020 and is expected to reach 8.7 billion in 2028. So why AMR grows so rapidly, and what factor plays an important role here? The growth of e-commerce has always been a key factor that boosts growth of AMR due to high labor demand in distribution center to handle booming number of coming orders. Then recently we have COVID-19 also gives a hand on e-commerce as people couldn't go out to travel, so that they have more time and money to stay at home to browse and purchase items through internet. Then the pandemic also makes situation of lacking workforce even severe. Therefore, implementing AMR seems to be the optimal option for company to stay productivity in such a situation. So here I would like to, as a warm-up, I would like to launch our first poll. We would like to know how many among attendees have started using AMR or robotic technology in their use case. Yeah, from the poll results, at the current stage, not so many people, not so many attendees have started there or have existing AMR projects at the current stage. But I think in the future, there will be more and more on this kind of a requirement as AMR really helps on no matter for efficiency or the problem I mentioned, like a lack of a workforce because of at the current days, more and more distribution center I face this kind of a problem. Yeah. So now I would say from the poll result, it's half and half. So around 50 of attendees have their AMR project. So I think that we could finish the poll and go to next page. So we know what's behind to push AMR. Now I'm gonna talk about the benefits it could bring. Name a few here. For example, not many people would like to take night shift, so that employer will need to pay more as an incentive to ensure continuous operation even during the midnight. And with the help of AMR, employer could then reduce labor cost and avoid workforce shortage. Besides, AMR is operating through accurate algorithms so that it can keep consistency and avoid mistakes even after long working hours. Thus, combined with the non-stop operations, it can increase the productivity. Besides, the AMR is linked to warehouse management system so that every step is recorded for better traceability. And due to the feature of AMR that it can move around the production line or warehouse so that it gives high flexibility in layout. I will talk more in later slides. And as you can see here, there are many benefits of AMR. And I would like to launch our second poll. We'd like to understand those who haven't used robotic technology, do you have any plan to implement it in the near future? And if yes, when is it? Yeah. Right. From the poll result, I could see around 50% of attendees are considering implement it in the future. yeah, that's good to know and interest. And yeah, we are here to help you. So we will share more information, and I hope this information will give you more details and as a direction for where to start at the beginning. Yeah, we will end the poll and move to next stage. So in this slide, I would like to showcase the possible applications which can be achieved by AMR. You could see there are different AMR for variable applications in this factory warehouse scenario. In the command center or on production line, few employees are working with a human-machine interface like a tablet or a computer to ensure everything works well and check on real-time operating data. Then in the production, packing, or delivery area, there are AMRs designed for different purposes. For example, there are equipment maintenance robots for regular maintenance tasks, so that the worker, like the human, could be relieved from this kind of a routine task, and then they could put their focus on more valuable tasks, like to analyze the root cause of equipment didn't work like expected. And then there's a sorting robot to sort the right package, or material handling robot to execute good-to-person task to reduce time employee spend to get exact item and increase efficiency. Or there's robot that could help to automate inventory management process or help on delivery. So through the evaluation of robotic technology, there will be more and more interesting robotic applications in the market. Here, we'd like to launch our third poll. I would like to know which kind of application you would like to address through AMR or robot. Okay, I could see the top one is material handling, and the second one is like a sorting robot. Yeah, I could imagine this. Yeah, this is result. And, okay, we will wait for 5 more seconds, then we go to next stage. All right, I'll move to next page. So I mentioned AMR give the flexibility and the flexibility for the layout. So here we'd like to talk more about how AMR could help to evolve the assembly line or packaging line. When AMR is each station within the production line, it could give the flexibility and the scalability. For example, after a certain station within the production line, and you would probably need to do additional QC test, while QC department is in different location, and you don't want to set up an additional QC station here, then the flexibility of AMR could allow you just move this station to QC department without too much hassle. Or you would like to add additional station for different tasks, you could also achieve through the scalability of AMR, since you could add as you wish, like after certain station, there will be one more station for production or kitting or packaging, etc. Then next, the AMR gives the interoperability with other departments. Like you could directly move the finished goods to warehouse right after the process, then arrange for packing or delivery. Yeah. So you have heard about good points of AMR, but we all know it ain't easy to develop one by ourselves. A solid robot will require many components to work seamlessly to function properly, and the integration for each component has been the pain point for most customers. Before we get into details, I would like to launch our fourth poll to understand what's your critical pain point while developing robotic project. And we only have 5, so you won't be overwhelmed by lots of poll questions. So yeah, this will be the last two, and in the end of the webinar, I will launch our final one. Yeah. From the poll, I could the most critical two challenges are the lack of complete robotic SDK and the integration of robotic hardware components like a sensor, motor, or microcontroller unit. Yeah. Yeah, this is what we expect as well. And later we will give more information regarding to what Aion has done and what we have created that could help to solve these two challenges. Yeah. So interesting to know. Thank you. I will move to next page. I mentioned to build a AMR is not an easy task. So it will require right combination between hardware components, software architecture, and the integration in order to succeed. So it's also important to have a seamless cycle from prototyping to production, especially for two important phases within this life cycle are prototyping and the development. And between these two, the most project fails in these two phases. So after requirement stage, the team in project start to evaluate different hardware components and the platform to understand the features and what they need. Then look into software they want to integrate, and there may be something needs to be developed from scratch and put everything together. Then the prototype is complete after this kind of a cycle many times, then you can move to next step. The team then bring the prototype to production with the continuous and iterative development and the testing phases. And we get to deployment where there might be points are not considered during your prototyping and the development testing phases. Then it's very critical to have the development and testing team to get a way to manage the software even remotely if it's possible, and maintain the robot through small update or full deployment if needed. The cycle continues with the feedback, lesson learned, and the improvement that will get to requirement stage of next iteration or next version of the product. Then this is the whole cycle, and I will begin with the hardware that Aion provide, and later I will pass the ball to my colleague to discuss about the software and what components we have put to help on this cycle to make it more smoothly. Yeah. Aion is the hardware manufacturer, so we provide different kinds of computing platforms that could be used for robotic development. And on the left-hand side are platforms based on Intel with the Intel CPU and the AI accelerator. If you are into NVIDIA Jetson, we have a Boxer solution that with the NVIDIA Jetson GPU. And if you need a platform with higher computing power, we have Boxer PC with a server-grade Intel Xeon CPU and the module with a multiple NVIDIA's accelerator or the NVIDIA GPU graphic card. Yeah. Our hardware platform serves a part of AMR. Many other parts are needed to form a complete AMR. The sensing unit, like a sensor, camera, for robot to perceive the environment, or the microcontrol unit to control movement of robot and control its interaction with the environment, and then the connection with the human-machine interface for operator to manage, control, and interact with robots in field. You can see there are lots of efforts that are required to allow every part of function, normally and do its job. So with only proper hardware platform is not enough. There are lots of integration needed to be done on software side to complete a whole AMR. I will then pass the ball to my colleague, Daniela, to dive into details of what's needed in software and what Aion has been done to speed up robotic development cycle. Yeah. Daniela.
Thank you, Owen. Hello, everybody. So basically, after looking at what has been done from our side on the hardware, it's important to put the picture together to also include the software part. I wanted to start talking about the software, talking about the most important and known part about robotics, which is an open source software framework called ROS. It started as a university project in Stanford in 2007. It's already used in many commercial platforms, and now it's already available in version 2, ROS 2.0, which is with most of its components already ported to the new version. ROS is a framework that contains a lot of open source implementation of common robotics functionalities and algorithms, and are organized into packages that we can group into a set of categories. There are categories we can mention are system and tools, mapping and localization, navigation, perception, coordinate frame representation, and of course simulation, which we'll see later more in detail. The current release of ROS 2, it's Foxy Fitzroy, which is currently supported, and it's a long-term support release, and it will be supported until 2023. There are minor releases every year, and the next long-term support will be available from 2022. Part of the ROS project is also important to mention the ROS Industrial Initiative, which is an open source project that extends the advanced functionalities of ROS into industrial relevant hardware and applications. ROS Industrial is supported by many important companies, both from hardware and software, from ABB to Intel, ARM, Microsoft, Siemens, Canonical, Microsoft, AWS, and so on. It's very important that ROS is used and supported by important companies, as it shows how relevant this framework is to robotics. Next. And we mentioned about ROS and evolution into ROS 2. So when ROS started, it started as a university project, and it grew rapidly into something very complex, but the initial architecture wasn't ideal. There were some gaps and some problems that were then encountered down the line while ROS got more used by many companies, not just developers. So it started the need to develop a new version over the years, which was developed to address many of the shortcomings that were in the first version of ROS. So some of the most important parts addressed are the removal of a master node called ROS core, which was creating a very complex setup, especially when you have to deal with a lot of components within a robot. Also, the real-time performance, which wasn't really addressed properly in ROS, is now part of the core of ROS 2. So ROS 2 works with real-time, both in Linux, and later we'll see also with microcontrollers. The node management, so the various parts of the robots are better managed now. And of course, the one capability that's very important in robotics today it's the capabilities to manage multiple robots and let them interact with each other. So these so-called swarm capabilities, which were tricky to do with ROS and were causing many problems during development and validation of such functionality of communication between robots. Also, ROS was not scaling very well, and with small processors was more difficult. Communication priorities, and sometimes the connectivity over the network was not reliable. But ROS 2 was a big improvement in the last few years, with all the major components being ported and also many more now fully supported within ROS 2, has addressed all these problems. And as you can see also from the pictures, the structure is much more organized and all focused in helps to serve the various applications on top of the robotic system. Next. Just to give you an overview of the ROS 2 architecture, you see now that user applications can talk directly to ROS client wrapper. Depending on the language you use for your application, you can interact with application wrote in Python or in C++ or many other components. This and communicate with the ROS middleware, which is the main component. And the ROS 2 middleware, the most important thing to mention is that it is built on top of DDS, Data Distribution Service, with a standardized way of managing data transport, providing a publish-subscribe data transport approach. Using DDS within ROS 2 is a great advantage over ROS, and it helps to manage communication across the various components of the robot in the same way, and scale the solution without concerns in terms of timing synchronizations and even also real-time requirements. DDS is a very strong technology that's used in many installations and even mission-critical applications. In fact, DDS has been extensively used in large utility installations, financial systems, even space systems, also in flight and train systems too. This middleware built on top of DDS is interfacing with well-known DDS protocol, some open source, some commercials. We can mention that ROS 2 supports eProsima Fast RTPS and Eclipse Cyclone DDS, which are the main open source supported DDS protocols. It's worth mentioning RTI Connext, which is a commercial version of DDS, which is also supported in ROS 2, and also OpenSplice, which is partially supported in ROS 2. Next. It's not, robotics is robots are very complex, and so robotics requires many components also at software level. But ROS and ROS 2 are an horizontal middleware which can enable many use cases and also applications. And ROS 2 extend its functionalities thanks to many other frameworks built on top of it. One of it worth to mention is MOVEit, which is the most widely used software for manipulation. It's used on over 150 robots. It has a very permissive BSD license, and so it's free for industrial, commercial, and research use. It incorporates the latest advances in motion planning, manipulation, 3D perception, kinematics, control, and navigation. And it's used in various kind of applications, from deep sea to outer space, and it's used by hobbyists, but also by many industrial business companies. And some of the companies using Movit framework are ABB, KUKA, Universal Robots, NASA, and Boston Dynamics. Next. I was briefly mentioning the capabilities of ROS2 to run into smaller processor, and thanks also to the project MicroROS, it's possible to run ROS2 compatible applications and components and nodes also in much smaller compute units, even microcontrollers. So with MicroROS, it was finally bridged the gap between robotics and resource-constrained microcontrollers. So MicroROS provides a microcontroller-optimized client API supporting all major ROS concepts. There is a seamless integration with ROS2. It's completely compatible with ROS2. It's very flexible and it supports multiple real-time OS. So MicroROS is a middleware that runs on top of your favorite real-time OS. It's worth to mention FreeRTOS, but in particular Zephyr OS, which is very important in industrial applications. Also here we have a very permissive open source license. There is a strong community and ecosystem that's growing over time, and it's developed with the long-term maintainability and interoperability in mind. Companies behind this project, of course, is Proxima, one of the main companies developing MicroROS, but also Bosch and Freiware are part of the ecosystem. Next. All these components will need to run on our systems, on our Boxer units, or as we mentioned, our Intel-based systems. But it's difficult to manage all this complexity in the software. Also, if we have to add multiple applications and use cases within the same robots, if we are adding intelligence, we are adding manipulations. But in order to do so, using a single system, it becomes more and more complex to maintain. For this reason, over time, many applications now have been shifting their setup from running on standard OS into containerized applications. So we have support for various type of containerization within our platforms. Worth mentioning the new project AAEON, which is becoming stronger and stronger, especially for industrial use cases, thanks to its isolation, security, and advanced usage also for real-time OS integration. Of course, our ROS can be run on top of Docker containers and Kubernetes, and our platform support also those software container applications, runtime, sorry. Just a brief mentioning that containers are important, and now with ROS2 it's much easier to integrate robotics application using containers, and making it easier also for companies to automate deployment, scale, and manage robots in the field. Next. And to complete the picture, here we put together the various components we mentioned. So we have, no matter what is the hardware, a containerized application using robotic frameworks, ROS, ROS2 mainly, AI inferencing application depending on the platform using Intel OpenVINO or the NVIDIA Jetpack. And these containers are running on top of either a standard OS or a real-time OS for what matters to MicroROS and microcontrollers. And that can be used then to integrate with a cloud component using third-party robotic cloud platform. It's possible then to manage firmware and driver updates, and deploy new Dockerized components of the robot, installing and managing new configuration, but of course also reading data and analyzing logs and information collected from the robots. The cloud services that we can connect to the robots can also enable seamless integration also for the programming of the robots, the teleoperation of the robot in case there is need of some remote control. And of course, any kind of remote maintenance that might be needed for a robot that's deployed on the field. These robots can be, of course, be scaled to thousands of units using similar architecture. And one of the architecture I want to show today, it's the platform developed by one of our ecosystem partner using this very concept. Next. So our ecosystem partner, Cognitive, is building, and now it's in a beta stage, Nimbus platform. It's a cloud-based platform that integrates all the components we mentioned and greatly simplified the process of autonomous mobile robots development, testing, deployment, and maintenance. The key elements of this platform are about simplified configuration, AI integration, which is becoming more and more important for robots, and fleet management, including robot analytics. It simplifies the robot application development with self-configuring drag-and-drop definition, robot definition interface. It can integrate AI and robot learning capabilities within its mission management and control application, and it leverages analytics data from the robots fleets to improve robots' behavior over time. Next. Here there are some screenshots of the application to showcase how Nimbus simulates, and how with Nimbus you can simulate and build a robot. The user interface is very convenient, and you can see, for example, your system that can be placed in the virtual environment, and you can define the robot pipeline connecting pre-made but configurable components with a drag-and-drop interface. The robot components and even local ROS workspace can be defined as containers to create fully modular and easy to upgrade platform. This pipeline configuration can be deployed then to connect the platform seamlessly. This is what we mentioned before. That's why also container technology is very important for robots today. After the pipeline is deployed and while it's executing, we can gather streams of information directly from the robots to monitor the system, read and store logs and information. In this interface that you can see here, also we can see vision and AI inferencing applications that are integrated within the robot pipeline using pre-configured ROS packages. We can visualize the output also as a direct stream from the robot itself for debugging or also for remote control. The deployed robots that can include either a single or entire fleets can be continuously monitored from the Nimbus platform. Topics and streams can be configured. We can limit to transmit information depending on the situation, the mission, or what the robots needs to do. Also depending on the sensors, frequency of sampling the data. But we can verify continuously the status of each component. The robot logs can be saved and later accessed from one place to easily review if there is any issue and improve that can be done on the robot. Also, the various collected data can be visualized in using different type of graphs, diagrams, maps and other forms of visualizations. And can you press play also? So here in this video, we want to see the actual flow of how a system works. And we have included a device, Jetson Xarian X, with a Z2 camera. We're going to add the components now for the camera and selecting the specific pre-configured module. Then we are going to add a local deep learning component with segmentation module. And then we drag the main output of the camera to the image raw input streams of the AI module. And we can now click and deploy, so the configuration is automatically saved and pushed to the robot. We now see the robot coming up and selecting teleoperation. We receive the live streaming of the camera with the AI pipeline just deployed being executed on the device. And we can also select different options from the output to visualize other sensor data. The platform itself is very useful, and it includes all the various components that we provide as base for all our customers. Of course, the customer can use only some of the components which are provided as open source, ROS2, the base operating systems, and all the components that we mentioned that are essential part of a robot architecture. Using Nimbus platform, you can extend and integrate this functionality seamlessly and much more easily. And then you can apply the various components that have been defined in your specific robot application. And now I'll give back the control to Owen for the rest of the presentation.
Yeah, thanks for Daniel detailed introduction on software part and what's the ability of it. So here provides an overview structure to summarize Aion's robotic solution. First, we provide options for different computing platforms. The two popular ones are Intel and NVIDIA. Then, like I mentioned before, only hardware is not enough. So we will also need the robotic SDK to ensure each component works seamlessly. So we have engaged with Intel, NVIDIA, and the partner within the robotic ecosystem to enable these SDKs. Regarding to Intel, we have OpenVINO for AI inferencing, one API for heterogeneous computing, and the RealSense SDK for 3D vision and SLAM. Besides, we also integrate the core of a robot, the ROS and the ROS2. And as for NVIDIA, we have Isaac SDK. So Aeon builds the Robotic Development Kit based on both NVIDIA and the Intel, which includes necessary SDKs for our customer to speed up robotic development. And leverage these kits with the SDK, customer can start robotic development right out of the box and quickly iterate to application level that could be implemented in field. Besides, don't forget about the integrate with the integration with the cloud management platform like Daniela mentioned before, such as Amazon, AWS, RoboMaker, Microsoft Azure, or third-party cloud platform like Nimbus. Yeah. So here we'd like to provide a bit more information regarding to two robotic kits we provided. Later, I will give a bit more details. So if you are interested about our robotic solution, you could check the link here. Yeah. Now let's move into details of the solution we have built out with our partner Cognitin This is upscale RoboMaker Pro Kit, which is based on Intel platform and with the integration for AI vision, compute unit, motor, and the wheels, and also the connection with the cloud platform. So this kit could be a good starting point for AMR development. It comes with a robotic sample application like a SLAM navigation, mapping, and object recognition, etc. So you could start building demo and iterate your proof of concept when you receive this kit. And the integration with the Amazon AWS RoboMaker allows you to simulate in virtual environment to quickly iterate your design ideas and deploy it to real robot when algorithm is optimized. So AWS RoboMaker also provides the fleet management service that you can use to manage thousands of robots on the field. Regarding to cloud management, this kit works not only with the specific platform, it also gives the flexibility with other platforms, like the third-party one created by our partner community, for example, the Nimbus. Yeah. And like I mentioned before, we have created Robotic Development Kit based on both Intel and NVIDIA. So this is the one based on NVIDIA. The purpose is to provide options among different robotic development platform. Yeah. Then you could leverage the kit we provide to get started quickly. And due to the container mechanism and the integration, you could scale up while you need more computing power for your tasks. For example, currently you start from 8 on CPU, and in the future you will need a Core i, maybe Core i 8 generation or 11 generation platform for different features or different computing power. You could easily scale up. Or for NVIDIA platform, you could scale up to just an AGX Xavier platform. I would say our kit is production ready in terms of compute, which is the core for robotic applications such as SLAM, navigation mapping, and AI inferencing, etc. Then you could switch the chassis, motor, wheel, or add additional sensors to match your specific use cases. Then here we'd like to share some customers that are leveraging our platform to create their AMR applications. Just as I mentioned before, with the compute-ready kit to take care of the core, customers can switch chassis and add different sensors and functions with minimum efforts, then create variable applications for different use scenarios. For example, this one is the application for hotel and the bank service robot. And because it's with the card reader and facial recognition, it could help to recognize the customer and help to speed up the check-in process, then take the customer to the right spot to wait for next step within the procedure. Or like this one, the security robot that is equipped with the cameras to move around the building to check if there is any suspicious person or behavior when office is closed. So it could help to reduce the efforts from the guard. Yeah. And the many more different use cases for variable vertical markets can be achieved by AMR. So here I would like to launch our Let's poll to understand in which vertical market you would like to solve through robotic use case. Taylor. For highest two are still in manufacturing factory or warehouse and the logistic. Yeah, I can imagine this result. And the third one is retail. Interesting, yeah. Yeah, so thank you. I will end the poll. And here comes to our Q&A section. And two more information, if you are interested in the solution we have built, you can visit our website. And if you are you have something that you think you could collaborate with us to build an interesting solution or application, don't hesitate to sign up here. And here are contact information for Daniela and me. So if you have any further question after the webinar, feel free to drop us an email. Yeah. And if you have any question, you could type in the question and the answer box, Q&A box.
Yeah, oh, and I do see a question in the chat box, actually, if you want to check that.
Okay, let me.
I can take that, actually.
Okay, let me, okay, can you expand, you mentioned production ready, can you expand a bit more on the algorithm maturity of SLAM and the navigation example, various lighting condition, indoor or outdoor? I'll just repeat the question so that for the people who just watched the recording, they could also heard about this, yeah.
Yeah, so if we're considering here our development kit, if it's used in conjunction with, of course, Nimbus and the support of robotics software partner like Cognitive, they for sure have various light conditioning taken into consideration, and that's for this reason they use multiple types of vision input. Their robots can be enhanced with LiDAR if needed, using different kind of vision camera from Z2 to Intel RealSense camera D435, D455, T265, and so on. And depending on the use case, the algorithm are optimized for the use case that the customer may require. So again, the complexity of the robot cannot make one size that fits all, but for sure the knowledge of the software partners that can help into using these technologies can help bringing the robot to mature and production ready state much more easily.
Yep, thank you. And we have two more questions in the Q&A box. First one is the partner, potential partner already using Aeon's products for their mobile robots application. So they would like to share the solution with the Aeon. For sure, yeah. We are glad to hear more details from you. So I also see from the Q&A that I know your information, and maybe you could drop me an email, and Daniela and I will be happy to discuss with you further on your use case and the application. Next one is, where can I find more information about Nimbus platform? Regarding to this platform, it's developed by our partner, and now it's under first beta version. So we already get some information, and now Daniela and I are doing the integration to put all the information together and put within the website I show here. the solution aeon.com robotic. So follow us, and more information regarding to Nimbus and our new applications or solution regarding to robotic will be shared from time to time in this website. Yeah.
And I want to add to this one, that of course the robots developed by Cognitive, either built on NVIDIA or Intel, they will also be supported by their Nimbus platform. So it will be possible to get the robots and then use the Nimbus platform to set up, manage, and control the robots as an initial setup of a robot using Nimbus platform. For sure, again, as mentioned by Owen, then more information will be available soon. But if you are particularly interested, you can contact us directly, because we can eventually discuss with Cognitive team if there is any possibility to access the beta stage, depending, of course, on the requirements and the needs that you might have.
Yes. Right. I think we don't have any further question. I think we would like to take this chance to promote our next webinar. So it's Aion Spotlight, which will happen in 26th of May. And it's talking about our newest product and the latest feature of it. So if you are interested, don't hesitate to scan the QR code and register. Then because we Aion keep innovating and always try to seek for new and interesting solution. If you are interested and think what we are doing is helpful for your project or for your project development, don't hesitate to follow us. Or if you have any question, then you can send an email to the marketing.aeon.eu account. Yeah. So I don't see any further question from QA box. I would like to thank you all for joining, and thanks Daniel to host this webinar with me and share the interesting information regarding to software part. Yeah, hope this webinar help you. Yeah, thank you everyone.
Thank you everyone.
Bye-bye.
Good afternoon.